Hey guys, it's Ms. Johnson and I'm here to bring you our notes video for Unit 2, Notes 1. Unit 2 moves into systems of equations. So our first notes for Unit 2 is on graphing system of equations. So our learning target for today, I can solve and graph systems of equations. So let's just talk about what a system is for a second. So an example up at the top says graph the two linear equations on the same coordinate plane and take a look at what you notice about those. So if I graph these two equations here, I have -5 as a y-intercept for that top one. And then I have a slope of 3, 1, 2, 3 over 1, count up 1, 2, 3 over 1, count up 1, 2, 3 over 1. And do that a few times to give yourself a line like that. Remember, it's always good to go across the whole coordinate plane. The other one I'll do in red. Y-intercept of +2 and slope of -1/2. So down 1, right 2, down 1, right 2, down 1, right 2, and so on. So there's the line for that one. Now when we graph these on the same coordinate plane, what we notice is that there's a point in which they intersect. That we call that the point of intersection. Okay, so that's an important thing to think about when we're looking at systems. Here's another system that we can just practice graphing on the same coordinate plane. The top line, y equals 3x minus 6. I'd start down here at -6 for my y-intercept, and I'd go up 1, 2, 3 over 1, up 1, 2, 3 over 1, up 1, 2, 3 over 1, and make my line from there. Now that other equation, 6x minus 2y equals 12 is not in slope-intercept form, so that's the first thing I'm going to take care of. I'm going to subtract 6x from both sides. That gives me -2y equals -6x plus 12. And then I'm going to divide by -2. And that gives me y is equal to +3x minus 6. And then when I graph that, I'm down here at -6 and up 3 over 1, up 3 over 1, up 3 over 1. And you'll notice that it ends up being the exact same line. So this system of equations ended up having the two equations, these two equations lie right on top of each other, one right over the other. Now, that's what a system is. A system is two or more linear equations graphed on the same coordinate plane, or two or more linear equations that are grouped together somehow. Okay, a set of two or more linear equations. And then the other thing that you might want to put in that box is the solution to the system is where the two lines cross or intersect, point of intersection. So the solution to the system is a point. It's a point, meaning it has an x and a y, where the two lines cross. Now, there are three types of solutions to systems. The first one is a system that has one solution, one point of intersection. It's where the two lines have different slopes and different y-intercepts. Another possible solution is ones that have no solutions, and these are lines that are parallel lines. Parallel lines have the same slope. Okay, so lines that have the same slope but different y-intercept, those are lines that are parallel and have no solution. These are different slope and different y-intercept. Then the last type of solution is kind of what we saw up in number 2. Those are lines that lay right on top of each other. So they end up being the same line. And those are lines that have the same slope and same y-intercept. And when that happens, we call that infinitely many solutions because every point on the line is a solution to both lines. So let's talk about our steps to graphing. They're pretty simple. It's kind of like what you saw me do in numbers 1 and 2. You're going to graph the first line. Make sure it's in slope-intercept form if it needs to be. Then you're going to graph the second line. Same thing. Put it in slope-intercept form if it isn't already. Then you're going to look for the ordered pair where they intersect. Find the ordered pair where they intersect. And then if they don't have a point of intersection, they're either parallel lines or they're infinitely many solutions. No solution, or infinitely many solutions are your other options. Okay, and again, that's if there is no point of intersection. All right, so let's flip over to the back and talk about, or do some more examples. You can skip that box at the top of your notes page. That can be taken off, so just ignore that. We're going to move on to number 3. We have the system y is equal to negative x plus 8 and y is equal to 4x minus 7. So these lines are both in slope-intercept form, which is helpful. I don't have to move anything around. I'm going to graph the first one. I have a y-intercept of positive 8, that's up here, and then a slope of negative 1, so that's down 1, right 1, down 1, right 1, down 1, right 1. And then as soon as you feel like you can, go ahead and make your line. And then the other line, I'll put that one up here in red. My y-intercept is negative 7, and I go up 4 and over 1. Up 1, 2, 3, 4 over 1. Up 1, 2, 3, 4 over 1. Up 1, 2, 3, 4 over 1. It's really nice when one of the points you make ends up being the intersection. But there you go. There's our two lines. Our point of intersection is right here. Now we just have to identify that point. And that point is over 3 and up 5, to the right 3 and up 5. So it's positive 3, positive 5 there. Let's just see if it matches our answer. And there it is. So positive 3, positive 5 is our solution. Let's try number 4. In number 4, I again am given lines that are already in slope-intercept form, which is good. When I graph these, I have the first one having a y-intercept of positive 6, so I'm going to go up to positive 6. And then my slope is negative 1/2, so down 1, right 2, down 1, right 2, and so on. And there's my line. And then the other one, I have a y-intercept of positive 1. So here's my y-intercept. Slope of negative 1/2 again, down 1, right 2, down 1, right 2, down 1, right 2. And if you remember what we talked about on the first page, how parallel lines have the same slope, you can see right here that these are lines that have the same slope. So these are parallel, so this is no solution. Because parallel lines will never cross. All right, let's take a look at number 5. In number 5, we're talking about Monica and Max Gordon. They each want to buy a scooter. Monica has saved $25 and plans to save $15 per week until she can buy the scooter. Max has $16 and plans to save $8 per week until he can buy the scooter. So the question is, in how many weeks will Monica and Max have the same amount of money? And how much will each person have saved at that point? So how many weeks will it take them to get to the same point, and how much money will they have at that point? Let's first start off by writing ourselves a system. We need an equation for Monica, and we need an equation for Max. So Monica's money is going to look like this. The money that she has is going to equal the $25 that she's already saved plus the $5 times each week. And I'll just call my number of weeks X. For Max, Max's equation, the money that he has saved is going to start with $16, but it's going to add $8 for each week that he saves his money. So there's my system. I'm saying again that X is the number of weeks, and now Y is going to be the money they have. Money saved. Okay, so now let's graph these two. I know that I'm going to start at y-intercepts of 16 and 25, so I know, and then I'm going to increase pretty quickly from there, going up 5 at a time and 8 at a time. So I don't think I'm going to count by 1, because if I count by 1, I'm going to be up at 25 all the way up here already. So I'm going to maybe count by 5. So if that's my 0, I'm going to say 5, 10, 15, 20 is right here. 25, 30, 35, 40, 45, 50, 55, 60. 65, 70, 75, 80, and then 85, 90, 95, 100, and then 100 takes me up to the top. Then over here for the weeks, this is the money. Here's the weeks. for the weeks, I think I'm just going to count by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I just counted by ones for the number of weeks. All right, so now let's graph Monica's equation. Monica's equation starts at 25, which is right here, and goes up $5 for each week. So up 5 over 1, up 5 over 1. And remember, my y-intercept was, or my y-axis was counted by 5s, so that's just really up 1 grid line over 1. Up 1 over 1. Okay, so there's Monica's savings. $5 per week. Now let's talk about Max's savings. Max starts at 16. Now Max is going to be a little bit trickier because he doesn't fall on grid lines like Monica's line did. Monica's line was nicely on the grid lines. But Max is going to start at 16, which is a little bit above the 15. And then he goes up 8 and over 1. And up 8 from 16 would be 24. So 24 and over 1 would be right there. Then up 8 again would be 32. So there's 30. 32 and over 1 is right about there. Then up 8 more would be over to 40 and over 1. Up 8 more would be 48, right about there and over 1. Up 8 more would be 56, right about there and over 1. And there is Max's line. So it starts a little bit lower, but it increases a little bit faster because he's saving more per week. So now that point of intersection looks like it's right about there. And we need to determine what number of weeks is that at and how much money do they have. So the number of weeks that that point of intersection is at 3. And the money that they have saved is over here at 40. So that's the next part of my question. They've saved $40 after 3 weeks, and that's the same amount. All right, last two examples, just two more graphing equations, but this time they're not in slope-intercept form, so that's the thing I have to do first. I'm going to first take these two lines and put them in slope-intercept form. The top one's pretty easy. I just need to subtract the 2x. So I end up with y equals negative 2x minus 4. The bottom one is going to take a little more work. I need to first subtract the 5x, so I have 3y is equal to negative 5x minus 6, and then I need to divide by 3. So I end up with y is equal to negative 5/3 x minus 2. All right, so now let's graph those two on the coordinate plane. I'll start with this one. This one is y-intercept of negative 4, so I'm going to come down 4. And then a slope of negative 2, that's down 2 and right 1. Down 2 and right 1. Up 2 and back 1. Remember that you can always go backwards. Up 2 and to the left if you want to continue in the other direction. Okay, and then the other one is a y-intercept of negative 2 and a slope of negative 5/3. So down 5, that's 1, 2, 3, 4, 5, over 1, 2, 3. Or up 1, 2, 3, 4, 5, and back 1, 2, 3. Okay. Oh, did I do something wrong here? No, that's right. Okay, let's try to just put one more point on the line and see if that helps us. I'm going to go up 1, 2, 3, 4, 5, and over 1, 2, 3. Ah, look at that. There we are. So my line is kind of hard to draw here. It's really close to that purple line, but it appears as if their point of intersection is right up here. Now my lines weren't very straight. Hopefully you're using a straight edge or a ruler so that your lines end up better drawn than mine are. But it looks like their point of intersection is right there. So let's figure out where that is. That is over negative 1, 2, 3, 4, 5, 6, and up 8. So that's negative 6 comma 8. And then let's just check our solution over here, and there it is. Negative 6 comma 8 is our solution. Awesome. That was a tricky line to graph. Okay, let's try the last example. Number 7. Negative 4x plus 2y is equal to negative 8. And y is equal to 2x minus 4. So I first need to put them in slope-intercept form. The bottom one already is, so that's helpful. But the top one, I'm going to go ahead and fix that one. I need to start by adding that 4x to the other side, so that's going to look like this. 2y is equal to positive 4x minus 8. There we are. And then divide by the 2, and I end up with y is equal to 2x minus 4. So then when I graph these two lines, some of us can already see what's going to happen here. I have y equals 2x minus 4, and then I'm up 2 over 1, up 2 over 1, up 2 over 1. And it looks like that. And then the other one, I'm down 4, and I'm up 2 over 1, up 2 over 1, up 2 over 1. And again, hopefully your lines are ending up a little bit more straight than mine are. Mine are not very good. But the two lines fall one right over the top of the other. So y equals 2x minus 4, y equals 2x minus 4. They ended up being the same line, or coincident lines, we sometimes call those, which means we have infinitely many solutions. Okay, so that's going to take care of our notes video for today. Don't forget to check off your notes sheet with Ms. Johnson before you move on, and thanks for tuning in.